Hello, this is Group 1's presentation of our Pokemon database. I'm Dexter Fredenberg and I'll be covering the introduction portion of this presentation. For the database we're creating, we decided to focus on the Pokemon trading card game. Pokemon's been around since the late 90s. It started in Japan and it's since taken the world by storm. The reason we chose the Pokemon card game is because there's so many ways to break down the cards into a searchable database. You could search Pokemon cards by their energy type, evolution status, whether it's a basic card, if it's a supporter card, an item card, a stadium card. You can search the cards by their rarity, by the value of the card, the condition of the card. There's just so much to work with the Pokemon card game, and this is the reason why we chose to go to this route. Pokemon card collectors, they have a lot of work they have to do. When they open up the booster packs with the cards, they're not organized. If you look at the top left picture, you can see all the disorganized cards right there, and then they have to slowly categorize everything and basically make everything organized. That's the goal of the database. The database is to do this for the card collector, so that not that they don't have to organize their card collections, but with the database now they'll be able to quickly search through this card collection without having to go through boxes of just trainer cards or boxes of evolved cards or boxes of the basic types or boxes of energy cards. The purpose of the database is organization ultimately. So users of our database, they'll be able to upload all of their cards from their collection. And then let's say that user is building a deck for a competition and they need to find a leaf type basic non-evolved Pokemon to complete their deck. That user's going to be able to just perform a search where they look up the energy type they're looking for. So leaf in this case, and then non-evolved. It's going to simplify the process really, really good. So we want to give our users the ability to search by sets and as well as evolutions. So let's say someone wants to search their collection for a particular set. In this case, from the picture, we have a 151 set. And then they want to look for a water type Pokemon and they want to see if they have the full evolution of Poliwag through Poliwrath. They'll easily be able to do this with our database. As mentioned before, not all card collectors are in it for playing the trading card game. Probably the majority of Pokemon card collectors collect the cards for money purposes, for value, which is why our database will give users the ability to search their collections for cards, for rare cards, high-valued cards, and they'll also be able to search other users in the system for their cards. This will enable them to do trades as well as sell their cards or buy cards from other users. In order to do any of this, though, we have to start from the ground up. We have to go over the requirements of our database, come up with use cases, data flow diagrams, entity relationship diagrams, as well as design a user interface. So the remainder of this presentation is where the other group members are going to go one by one through these processes and go into the details of how we're going to bring this database to life.
So we're going to introduce the requirements definitions, and we're going to start off with the functional requirements, you guys. First is account management. It's essential that our platform allows users to seamlessly register, log in, and manage their accounts. We're also implementing a password reset feature to ensure user convenience and security. Moving on to collection management. Users should have the ability to add and remove cards from their collection effortlessly. To even streamline this process, we incorporate bulk upload options. In addition to that, we're going to enable users to categorize their cards based on various criteria such as value, rarity, type, hit point, collection number, and card stages. Next is our search and discovery functionalities. Users can easily search within their collection and pinpoint specific cards using, once again, filters like value, rarity, type, hit point, collection number, and card stages. Our fourth is the trading and selling aspect. Our platform facilitate seamless transactions. So users can list their cards for trades or sales and specify details such as the condition of the card, asking price, and even browse through available listings. We've also included a feature for users to make offers on cards listed by other users. So we want to foster a dynamic trading environment. Moving forward, users can create and manage wish list of cards they want to acquire. So our system will be able to notify them what card on their wish list becomes available for trade or sale. Next is communication. Effective communication is crucial in any trading community. Therefore, users should be able to send messages to each other to negotiate trades or sales directly with the platform. And this should ensure smoother interactions. To keep users informed and engaged, our platform is going to provide notifications for important account activities, alerts for wishlist matches, or responses to the listings. Furthermore, users have the opportunity to advertise their cards or related merchandise on the platform, with options for featured listings or advertisements to increase visibility. Our last functional requirement will be deck building, by allowing users to create potential deck lists and track their prices. So the database browsing feature enables users to quickly identify cards that match specific criteria, streamlining the deck building process. Next, let's talk about the non-functional requirements that underpin the reliability and performance of our system. Our platform prioritizes responsiveness and scalability, ensuring that it can handle multiple user requests simultaneously without delays. And security is very important. User data, including personal information, transaction details, is securely stored and encrypted. Robust authentication and authorization mechanisms further safeguard user privacy. Designed with scalability in mind, our system can easily accommodate a growing number of users and data, ensuring seamless performance as our platform expands. The user interface should be designed to be user-friendly and intuitive, catering to users of all technical backgrounds. We want to provide a seamless experience that lets users navigate the platform effortlessly. Fifth is reliability. High availability and minimal downtime are fundamental because users should be able to rely on our system to be accessible whenever they need it. And to maintain data integrity, measures are in place to ensure the accuracy and consistency of data within the database, providing users with reliable information for their trading activities and collection management activities. Finally, our platform should adhere to legal regulations, including data protection laws and user rights and privacies. So in conclusion, these requirements are going to guide the development of our platform.
Hi, this is Nicholas, and this section will be covering our project's use cases. Manage collection, add new card is our system's first use case. This use case documents the registered user adding a new card to the database system. A new card can be added to a user's collection through inputting key identifiers relative to the desired playing card. If the user's inputted card details cannot be matched via the Pokemon TCG API, the user will be prompted to enter different identifiers or card details. Our second use case is called Manage Collection, Sort Collection. This use case documents the registered user accessing the sorting feature of our database system. The user is able to sort their collection of cards by their monetary value, rarity, energy type, hit points, expansion, and card type. After the user has selected their desired method of sorting, the database system will automatically display the user's desired sorting specifications. The system will also maintain the user's sorting preferences upon future logins by the user until the user has decided to change their sorting preference. The user will be asked to choose different sorting criteria if no cards are returned, or display an error message if an error occurs during the sorting process. The third use case is titled User Search. This use case documents the registered user utilizing our system search functions. Users are able to search for owned and unowned playing cards in their collection, as well as other users' collections. The user may be asked to re-enter search criteria if no results are returned. Use case 4 is titled Create, Sell, or Trade Request. This use case documents the creation or acceptance of a selling or trading request of a particular playing card. The seller or trader and the potential customer are both registered users of the system. In order for the sell or trade request to be complete, both parties must agree to the terms and preferences of the request. The listing of the card itself will then be publicly considered as accepted. The messaging feature of our system can also be used for both parties to interact. If a dispute is necessary, the system will take into account the listing that is being disputed. Use case 5 is titled Add or Remove Card from Wishlist. This use case documents the registered user adding or removing playing cards from the user's wishlist. Users are able to add cards to their wishlist by searching for the card they wish to own. The user can also remove a card from their wishlist via the My Collection tab. Use case 6 is simply titled Communication. This use case documents the registered user's communication with other users within our platform. Users are able to message one another from a playing card sell or trade listing. This allows users to get more details about the physical condition of the card or other information, as well as negotiating the price or trade offer of the card in the listing. After the listing has been accepted or completed, the users involved in the transaction or trade may provide feedback on one another. The possibility of users not responding to messages is likely, and the ability to block or report users is also allowed. Use case 7 is titled User Notifications and Alerts. This use case documents how the registered user will receive notifications and alerts for their account. Users who enable notifications or alerts are able to receive notices whenever a card on their wishlist is being sold or traded by a user on the platform. While alerts and notifications are on by default, the user can disable all notifications and alerts, or simply choose which specific card in their wishlist, or even for a specific listing, the user desires notifications for. Possible notifications and alerts can be for price updates, message notifications, new listings, or when a listing has already been accepted. Use case 8 is titled Advertising and Promoting. This use case documents the registered user's ability to advertise and promote their trades and listings. While a user can simply publish a listing or trade, there is a high likelihood that a user's post may go unnoticed by other users. While this can happen for a variety of reasons, it is nonetheless helpful and in users' best interests to advertise and promote their listings. While optional, users may purchase a promotional feature that allows their listings to be advertised to other users on the platform. Promoted listings are noticed first by other users compared to other listings without the optional promotional feature enabled. Users are also able to analyze advertisement analytics for their promoted listings. Our last use case is titled Deck Building. This use case documents the registered user's ability to create a Pokemon deck. For users who play Pokemon TCG casually or competitively, our platform's deck building feature allows users to create a Pokemon deck that can indicate the specific cards not owned by the user, the cards in the user's deck already in the user's collection, and even provide the overall estimated value of the deck. This deck building feature allows users to see what card they're missing from the deck they want to build and can then purchase or trade for the cards they need. In certain circumstances, this may be a cost-effective option for users that already know what card they need, rather than pushing their luck by buying playing card booster packs that may not contain the card that they need.
Next, let's move on to the data flow diagrams. In the following slides, we'll be seeing three different types of diagrams, one being the context level, or also known as the top level diagram. Next will be the level 0 diagram, and lastly, the level 1 diagram. Before we go in depth into these different diagrams, let's first summarize them. Now, the context level diagram really is just more showing the process of interaction with the system. The interaction from the system with external entities. As you see here in this picture here, it's a perfect representation as the yellow boxes, as you see here, the student department and admission portal are the external entities that are interacting with the system. Next is the level 0 diagram. Now this diagram will show all the processes that comprise in the overall system. It's basically a lot more elaborate diagram starting from the context level diagram. It just shows a lot more processes and a lot of more data flows that occur within the external entities with the system. And also it includes data storages, which are just repositories of data in the system. And lastly, the level 1 data flow diagram. It shows all the processes that comprise a single process on the level 0 diagram. So basically, it's a decomposition of each process that we will see in the level 0 diagram. So here we have the context level data flow diagram. As you can see, we have two entities in our diagram, one being the user and then the receiving user, or also known as the other user, that will be receiving data from the sending user. Now the level process here would be the Pokemon app. That is the system that they're interacting with. The processes within the app are as follows: is to create an account, to search a card, messaging, and card listing. And again, in a context level diagram, we have no database. Now we are moving on to the level 0 data flow diagram. And the only entity here is really the user, as the user has to create an account and register. They could add cards to their collection. They could search cards by filtering, and they could message other users within the app. They could buy and sell cards. And lastly, the database here is the collection database, which basically is just files of data and information of their collection or any cards that are within their account or tied to their account. Now lastly, we're moving on to the level 1 data flow diagram. Now in this diagram, it is quite elaborate and there are high level of processes going on, so I did not list them in this slide, but I will go ahead and explain them. Now the external entity here is the user. The user has to confirm their account by signing in, and also the system will be able to authorize that sign in. Also, they could make any changes by adding to their card collection and then updating that on the user database. And lastly, of course, the database will then confirm and validate that request. Next, also, the user could search for the cards, send a request to the database, and then that database will return that data or information back to the user. Next is also the card listing. If the user is requesting to add a new card onto their account, that is going to interact with the database, is going to make the change and also validate and confirm with the user. Communication is very important and has to go through many security protocols. However, the user could interact with other users within the app. And then, so here you can see a new message is sent and sent to the recipient and to their inbox. The user will then reply, and then the recipient message will send the reply message to the user. And lastly, the notifications. Really, this is just them interacting with their own system, with their own account, and then either turning on or off the notifications and alerts of any new listings or any new relevant information or updates to their account. Lastly is the advertising and promotion. Now the user could also request to add advertising features to their new card listings, and it'll help them expedite their trading process. And of course, all that information that that they purchased will be recorded onto their account, and that database will save that information and return it back to the user.
Hi everyone, my name is Scott, and I will be talking about the foundational structure of our card collection management app, the Pokemon management app. I will be focusing on our entity relationship diagram and how we've harnessed information we've got from our own tables we've made and the Pokemon TCG API to enrich our app's functionality. As you guys are all aware, it's important to determine exactly what information you want to track in your app, what you need from your users, and what you want to be able to provide to your users. As we began this stage of our development, we could easily determine that we needed entities like user, collection, card, and set. And for those of you curious, set refers to the group of cards released, like Ruby and Sapphire or Fire Red and Leaf Green. Identifying these was intuitive, but defining the specifics of the specific attributes, especially for cards, posed a unique challenge. It was crucial to determine not just what information we wanted to track, but how to make the app valuable and comprehensive with complete data for each card. We got lucky, and as we were working on building out our app, we found the Pokemon TCG, which stands for the card game API for developers. For anyone who might have forgotten or who doesn't know, an API is an application programming interface that serves as a bridge between different software platforms, allowing them to communicate with each other effectively. In the context of our project, we plan on utilizing the Pokemon TCG API as a digital resource that provides detailed information on these Pokemon cards. This API provides access to a vast database of card attributes, such as names, descriptions, images, and much more. And we'll go into a little bit more of that later. By integrating this API into our app, we're able to automatically pull in up-to-date information directly from the TCG database, ensuring our app's content is rich, accurate, and dynamic. Here on the right, you can see the full list of attributes available to us as users of the TCG API. And while we don't need to use all of them at every stage in our app, we plan on making all of this information accessible to our users so that they don't lose out on any of this enriching information that should be available to them. Because we were using this as a framework for our app, we needed to find a way to link these card items to the individuals to own them, as well as to the physical card and to the collections in which the users might want them. Let's say a user wants to collect all the cards from a certain set. They could put it in one collection, or if they wanted to do a deck that did one thing, that had a particular goal, they might use the same card in multiple decks. So that was a challenge that we needed to solve. Here you can see our ERD. For our purposes, at this point we decided not to show all of the small foreign key tables associated with information in the card table. As you can see, things like ancient trait, abilities, and attacks. All of those things are stored as hash values. If we choose to use a database like MySQL, they'll be broken out as subtables. If we use a relational database, something like MongoDB, then they will be broken out as hashes. Really, the focus of our ERD is allowing users to put their cards in multiple collections. So you can see here that we have user cards is a table that connects user and the individual cards they have, allowing them to connect cards to collections, and the user can own multiple collections.
Hello everyone, my name is Kieran and I'm going to present the section about our user interface. The first part I want to talk about is our choice of color for the user interface. Being a Pokemon card collecting app, we knew that we wanted colors that were associated closely with the Pokemon brand. This led us to deciding between two main color options, which were blue and yellow or red and white. Blue and yellow represents the colors of the Pokemon logo that came out in 1996, and which has not seen any major changes in even 27 years later. It's a logo that's instantly noticeable and that people are likely to appreciate. However, upon trying it out, a blue to yellow gradient did not really give off the impression that this was a Pokemon trading card game app or that it was associated with Pokemon at all. You can see an example of this on the screen right now. The impression that this color scheme gave off was more akin to like a banking app or maybe a workday style app. That brings us to the second color option, which is the iconic red and white of the basic Pokeball. Not only is this color scheme recognizable, but Pokemon fans will likely subconsciously make the connection between the color scheme being that of a Pokeball and the collection aspect of the app, which is a bonus. This is just an initial design. However, I would like to flip the gradient so that it goes red to white at the bottom, and maybe add black to represent the black ring around the Pokeball to really drive the message home. An alternative color scheme based around the Master Ball colors was also thought about. However, creating a setting for the user to change themes seemed overly complicated and offered very little in terms of improved user experience. Moving on to the general layout of the app, you can see that the name of the app is at the top, a tab that will take you to view popular cards is at the bottom, and there is an included search bar and filter, allowing users to easily find cards that they are looking for. Based on similar apps like TCG Player, we have found that having the card as a large part of the visual display is very popular, so our app will have the cards fully visible so that a user can clearly see the card text before even needing to click the card for more details. Additional features that we noticed and would like to add would be a featured cards section, which acts similar to our popular cards tab, and a way to show market price data to the users. Here's an example of what we would like our card database to look like to the user. It looks almost identical to the My Collection portion. However, the title at the top is changed to Card Database, the Owned section is changed to Popular Cards, and the Wishlist portion is replaced with Recent Searches, just in case the user wants to go back to a card or needs their memory jogged when it comes to finding something. In order to display other cards, the user will need to use the filters and search bar in order to keep the system from displaying too many cards at the same time. The final part of the UI that I would like to go over is the general features of our app. On the left, you can see a concept of our home screen. We tried to make it extremely simple so as to not confuse users, and we have made the menu labels extremely clear. The My Collections button simply allows the user to access the storage database that contains all of their own cards and their wish list. It allows them to easily filter through and manipulate both the cards in their collection and their wish list. The card database is similar to the My Collections feature, except it shows all cards currently available, regardless of if the user actually owns them yet. This is the tab the user will go to add cards to their wish list and to find cards that they would like to trade or buy. And finally is the Mail tab. This is where we will send the user notifications and is also where the user will go to message other users. As you can see, we would like the users to have the ability to create their own usernames and upload their own profile pictures. And we would like to give the user the ability to also filter through these messages between those that have already been seen and those which have not.